All right, this lesson is 3-5 related rates. This is the hardest part of derivatives because it's story problems and students hate story problems. But if you follow these steps, it will help ease your pain, we should say. So here are some procedures. The first one is draw a picture if possible. Sometimes a picture can help your brain get thinking of how you need to proceed. The next thing that you do is write down everything that's been given, and you write down what you're trying to solve for. So if you notice now, we're differentiating with respect to dt because it's with respect to time. We're not doing x. We want things changing with respect to time. We're going to be talking about volume, areas, and if you look down here, here is some formulas that, yeah, you need to pretty much have memorized. And those ones you should have memorized. The hardest ones are the sphere and the cone. But I have noticed on the AP test, they do give you those formulas. But, you know, try and work on getting them memorized. I know it's hard, but you should know a right triangle, your circle, and cube, and rectangle. So step 3 then is once you write down everything you have and what you're trying to find, you need to come up with an equation that relates everything together. Now these 3 things you need to watch. I'm sorry, it keeps doing that loud sound. If a quantity is changing, it must be represented with a variable. Very, very important. B, if it's constant, it must be represented with a number value. And sometimes on C, this one doesn't always happen. Look for secondary relationships between quantities that help you reduce variables. That normally happens on our cone problems. Step 4 then, we do implicit differentiation with respect to t, solve for whatever dt, and then substitute everything we know into the equation. So we're just going to practice basic, no story problems involved, how to differentiate area problems with respect to time. So we want to take the derivative of area equals side squared. So if we take the derivative of a, and if you notice over here it says find dA dt. So what's the derivative of a? Well, that's dA. But this time everything is dt, so nothing's going to cancel out. So you need to write whatever variable you are, take the derivative over dt. So then on this side, what's the derivative of s squared going to be? 2s ds dt. Well, they obviously have to give us information if they want to know what dA dt is. So they tell us the side is 4. So I thought that was a negative 2 times 4 times 3, which is 24. Okay, now units are very important as well in these problems. If we're talking about an area, area is what type of units? Well, they're squared. They didn't talk about units here, but I'm going to. So let's say it was feet. So then I write feet squared. But since it's with respect to time, say that is minute. So the area is growing 24 feet squared per minute. So keep in mind, if I start to talk about volumes, then what should my units be? Then I'm going to get into cubed, feet cubed over minutes. So areas are squared, volumes are cubed, and linear, of course, it's just would be feet per minute. So hopefully that makes a little sense. Always check your units, very important. Okay, B. We need to differentiate xy equals 12. And if you notice, it gives us dx dt and says find dy dt. Product rule. The derivative of x is dx dt. Leave y alone, plus, now take the derivative, leave x alone, take the derivative of y, equals 0. Plug in, well, we're trying to solve for dy dt, so I need to get that all alone, so subtract that over. I'm going to come right there, dy dt, add my x, equals negative y over dx dt. Last move to get dy dt all alone, divide by x. Now, plug in what you know. I'm going to come up above dy dt equals negative y, which is 4, negative 4. What's dx dt? Is negative 6 over x. Oh, we have a problem. I don't know what x is. Well, come back to here. If we have an equation, and we have x and y equals 12, and we know what y is, then that means x would have to be what? It would have to be 3. So then, that's 2. We get 8. So dy dt is 8. This, I don't have any units, so I'm not going to put any on there. Okay, so hopefully that kind of gets you warmed up. Now we're going to see an actual story problem with this. And I always tell the students, first, just read the problem. Don't think about anything, just read it. So I'm going to have you do that right now. Hit pause, read the problem. Then I want you to go back, and then you read it again, and then write what everything means. So I'm going to be doing that part. Okay, a windlass is used to tow a boat to a dock. The rope is attached to the boat at a point 15 below the level of the windlass. So I'm like, okay, numbers. Those numbers are normally important. I want to highlight in a different color though. So I always go through and start highlighting stuff. Okay, if the windlass pulls the rope at a rate, the minute I read the word rate, I know I am talking about a derivative. So I highlight rate to remind me and keep that. And then I can see it's a derivative because I see that feet per minute. And keep in mind, we need to say, well, what is that rate referring to? The windlass, okay? Which is then describing this part right here. So if you notice, that part was called the, and if we're taking the derivative of that, that means we know dz dt equals 30. If you want to write your units, that's fine. Feet per minute. Okay? At what rate? So here's my question. At what rate is the boat approaching the dock? So here's my dock. So we're trying to figure out this right here. So I'm going to take the derivative of x. So dx dt is my question mark. Let's see. When there is 25 feet of rope out. So this would have to be 25 feet of rope. Then write a sentence explaining what your answer means. Okay, they were nice. They gave the picture. If they didn't have the picture, you probably would be pretty stuck and have no idea of where to begin. But since they have a picture here, looking at what you have and what you need to find, what type of equation relates all this together? Well, let's talk about why is that 15 and not a variable? Is that windlass going to shrink height at all? Remember, it's being held at a constant, so it stays a number. Is z going to stay 25? No, it's changing because we're pulling that in. So I need to leave that as z. So hopefully you realize this is the Pythagorean theorem. 15 squared plus x squared equals z squared. So here's the equation that relates to my questions that I have. So once I have my equation that relates to what I want, we need to take the derivative. What's the derivative of 15 squared? That is 0. The derivative of that would be 2x dx dt equals 2z dz dt. So once again, why did we not plug in the 25 for z right now before we took the derivative? The reason being is because that z is changing the whole time. We're just saying at some point it will be 25. This is when you would plug your 25 in now after we did the derivative. So as we start to do this problem, we have 2x, well, dx dt, that's what I want to find, equals 2, well, z is 25, and dz dt is 30, so I have 2 unknowns. I still have a problem here. How do I know what x is? Well, come back to your Pythagorean theorem. Now I can find x if I know this is 15. At a point when this is 25, what will x be? So I'll have 15 squared plus x squared equals 25 squared. Solve for x squared, and that will be 25 squared minus 15 squared, which then gives you x equals 20. So we know that is 20. So our last move is to solve for dx dt, which means I can divide that to the other side. Okay. I didn't simplify anything down, which would be 2 over 25 times 30 divided by 2 over 20. The 2's cancel, the zeros cancel, and then you could just leave it like that. You could write it as a fraction. Oh, sorry. Dx dt then equals 75. I don't know where I wrote to. Well, I do. I was thinking of the bottom number. 75 over 2. Now, what are your units? We're talking x, and so those units are, what were they? Feet per minute. Feet per minute. Right there. Okay, 1 second real fast. All right, sorry. Okay, so one other thing that I missed that we need to take note of is what's happening with this distance with x. That's my marker. It's moving in, so that distance is shrinking with the boat moving in, not x, the distance of z, because that rope is pulling it in. So this needed to be a negative. So sorry, I totally forgot that when I got here at the end. I started thinking that. The reason I knew something was wrong because this means something is growing if it's positive. And I know that distance isn't growing, that distance is shrinking. So it needs to have the negative there. So sometimes if you forget it, like I did, you need to go back and think about this part right here. So now we have to explain what it means. So it says we're changing, dx dt is decreasing at a rate of 75 halves feet per minute. So that distance is shrinking. Okay? So that's why the negatives are important. You cannot forget them like I did. But like I said, I knew there at the end something was wrong because I needed my negative in there, and it was coming right there because I was pulling that in. It's got to be negative. If you forget, then double check when you hit this answer. I know that distance is shrinking, which means I need a negative. I know there's a lot involved, and it comes with practice, so don't get too frustrated. So for your extra credit this time, I want you to write who is your favorite character. Favorite, just favorite person. Write that down and turn it in on my desk quietly and discreetly, and you will get extra credit. Don't tell anyone. Okay, we are on our last example right here. So read the problem, then go through and highlight. So we're at gravel's falling onto a conical pile at a rate of 10. Always look at your units. Cubic feet per, I think that was minute. So I know that has to be a volume because of my feet cubed. And it's a rate, so dV dt equals 10. I'm not going to write units, okay? At all times, the radius, r, is twice the height. Find the rate of change of the height. So I want to find dh dt is my question mark when the radius is 6 feet tall. Then write a sentence explaining what this means. So I'm talking about a cone. I'm talking about a volume. What is the equation? Volume equals pi thirds pi, don't need to write it twice, r squared h. Okay. Is it? Yep. Okay. So as I look at this, I have two variables, and it doesn't talk about drdt. So I know I want to get rid of my r's because that would throw in extra variables. I would have to do the product rule. So they gave me extra information here to help me wipe out the r's, and it's that fact right there. So you need to sub that in before you take the derivative. I'll come right here to it. So I have pi thirds. R is now 2h squared times h. Once again, still clean that up doing algebra. That squared has to hit the 2 and it has to hit the h. So volume now is 4 pi, just brought the 4 out front, don't worry, over 3h cubed. Now this is looking better because I'm down to the variables I'm wanting and looking for. So now we're good to take the derivative. The derivative of v is dv dt equals, now take the derivative of h. The 3 comes in front. H squared all over 3. Took the derivative of h. Now I write dh dt. My 3's go away. Now you can plug in what you know right now, or you can do it at the end. It doesn't matter. So dv dt is 10. I'm going to kind of do both, sorry. Solve for dh dt. So over 4 pi. Now what is h? Well, I know what when r is 6, so how do I get h? We'll come back to this thing. We know r is 6, 2h divided by 2. So h is 3. 3 squared is then 9. Simplify, and we get 5 over 18 pi, which equals dh dt. Now we need to get my units in here. We're talking about a height. So as a height, is that going to be single unit, squared, or cubed? Well, it's a height, so it is single, so it is feet per minute. And this should make sense. My pile is growing, so there should be no negative. If I ended up with a negative, then I know I messed up somewhere. So I know this answer makes sense. So how I explain this, I say the rate at which the height is changing is 5 over 18 pi feet per minute. So the height is growing, increasing. You need to say that word because that acknowledges the positive part of it. So the height is growing at a rate of that fraction feet per minute. Okay, that is the end of 3-5. And don't forget your extra credit.